All right, so I'm going to take a minute just to show you how to code in C# using Unity, how to pick up objects in VR. It's going to be a little bit intermediate, maybe just a little bit tricky, but the payoff is huge. It is so much fun. So, hey everyone, how's it going? My name's Eric Tereshinski, and you are watching the Master Indie YouTube channel. So yeah, before I jump too far into this, I just want to say I'm going to be starting my Twitch live stream soon, where I am going to be developing my own virtual reality game, Jet Island. Check that out if you haven't already. It is a ton of fun if you don't get motion sickness. It's super extreme. You slide around on your hoverboard in a giant open world. You can swing on hook shots. You fight crazy giant monsters. Everything has a retro art style. It's really, really cool. I'm going to put a link to it in the description below. So yeah, why don't I go ahead and switch to my desktop view. And before I jump into VR, I just want to do a quick overview of this script so that people who are watching this who are already advanced coders who just want to know the secret sauce of how to make the physics programming work. Basically, this is the secret sauce right here. We have a whole bunch of stuff here. You need to include using Valve VR. You got to make sure that you get your left and right hand sources. You got to make sure that you go through this window here that's a SteamVR input and you generate a new input profile. And then from there, you can check to see if we're holding down the trigger. And then we check to see if there's a gun nearby to pick up. And if there is, then we pick it up. But we don't child it to our hand. It's still free floating away from our hand, but we make it feel like it's in our hand using physics. So yeah, like I said, here is the secret sauce. We add velocity, or we just, every single frame, we manipulate the velocity to make it move immediately into our hand using real velocity physics. And then we do the same thing with angular velocity to make it rotate into our hand, which is, just a little bit more complicated. As you can see, it involves a few more lines of code, but it's not as complicated as it looks. I'm going to break it down. But yeah, that is pretty much everything you need to make it work. So why don't I go ahead and now jump into the game so you can actually see all the cool stuff you can do in this game. It's really, really awesome. So let me switch to the desktop view. Let me switch microphones here. All right, and sorry that I'm doing this all in one take. I don't really have time to edit these tutorials if I'm gonna make these a part of my weekly routine or whatever. So I'm just gonna try to get through this really, really fast, but also keep this concise and a great learning experience. So yeah, where to begin? I have a whole bunch of different guns on the ground. First, I started with these guns here. It's not really lined, this particular gun's not lined up with your hand. It's just a test object. But you can see I can grab, I can drop, everything has real physics. When I push it against a wall, the gun stays, but my controller goes through, and you can do that in any direction. It works really good. I can pick up two guns, I can whack them against each other, which is really much more fun than it should be. I can hook the guns against each other. So yeah, there's a lot of cool things you can do. And then, yeah, here are, get that out of here. Here are some regular looking guns. I have them actually lined up with your hands. I'll show you how to do that. It's not too terrible. You just do a child and you just like offset, and you just got to keep putting on the VR headset, hold it in your hand, be like, oh, it needs to rotate forward, it needs to rotate back, it needs to be bigger, it needs to be smaller. You just adjust it a couple times and then you eventually get it in your hands and everything works perfectly. But yeah, there's so many things you can do. Like you can do gun juggling. Flip the gun, that's a lot of fun. Under the leg, yeah. Smack that gun away. Also, I have guns with different physical properties. Oops, whoops. As you can see, not that, get out of here. Eventually we'll have to update the script to make it so that you can like selectively pick up what gun. Right now it kind of is a little whatever. But yeah, so we have a bouncy gun here by changing the physical properties. So you can see, like, if somebody is like, hey, or wait, I need one gun for this. If somebody's like, hey, drop your weapon, be like, okay. Ha. So yeah, those are bouncy guns. Those are a lot of fun. Whoops. Try that again. Bounce. Another funny thing you can do, check this out here, I'll do it on this like podium. if you push it, it starts bouncing like crazy into the floor. And then if you let go, oh, let's try again. Oh, I was doing it last night. Wait, into the ground and let go. Ah, you're supposed to fly up in the air like a rubber band. There it goes. So that's a lot of fun. See if I can catch it. Nope, it's too far away now. And then the other gun we have is the slippery gun. So if I slide it on the ground, you can see it is basically like a bar of soap. Slide that. So that's a lot of fun. You can like push guns around with other guns. You can use guns to pick up guns like a chopstick. So is this the correct way to do gun safety? Whoa, I'm looking down the barrel. Don't want to do that. And it's really funny. So if you try to do that with the slippery guns, it's like a bar of soap. It's like so hard to pick up the guns. And what's funny is like this could actually have real tactical value. Like imagine a stealth mission and you want to pass the gun to somebody. You can just be like, quietly like slide it across the room. The other person can pick it up. Another cool thing you can do with your slidey guns is gun bowling. Let's see. I knocked down a gun. Let's see if I can get how many guns I can get. Right, I gotta line it up with the lines on the ground. And gun bowling. Yeah, 3 guns. I knocked down 3 guns, new high score. But yeah, this is a lot of fun. There are so many possibilities. Once you make it so that you can pick up an object, you can replace those objects with any shape object, any weight object, bouncy, slippery. There's just like so many possibilities. You could do like zero gravity and start knocking around zero gravity stuff super easy. There's so much stuff you can do with just this one tutorial. So yeah, let's get into it and let me show you how all this code works. Oh, I'm a little bit out of breath. All right, here we go. Back at the computer. Everything's still recording good. Oh, dang. I hope this video doesn't go on too long. It's already been about 7 minutes or so. Okay, so let's see. So let me first just quickly explain how we're going to do all this stuff. All right, so we are going to first check to see if we're picking up the gun. So in order to do that, we need a button. So we're going to assign a button to the trigger, and then we just check to see if we're holding down the button. We're going to do something called a sphere overlap check, like physics.sphere overlap, something like that. And that's going to check the whole surrounding area. And we're going to create a physics layer called pickupable. So every game object in the world, we're going to assign this pickupable layer. And then when we do this sphere overlap check, we're basically checking an area to see if it has any physical collisions with anything with this pickupable layer on it. And if so, we're going to grab the rigid body component, which is basically the physics component of the game object. We're going to grab that, save it into a variable. We're not going to child the rigid body to our hand, which means to like physically attach it to our hand. Really, it's still going to be its own separate game object that's just floating around. We're just going to save that in a variable and tell that rigid body to move to our hand. We're just going to give it the force that it needs, the angular velocity that it needs to rotate into our hand, and the regular velocity in order to move into our hand every single frame. So it'll just snap to our hand, but do it using physics. That way, if it collides into a wall or another rigid body object on the way to your hand, it will be stopped or apply force. So even like rotating things, you can like smack things and it will all be realistic. So let's jump into desktop view. And first of all, you need to download SteamVR plugin from the Unity Asset Store, import that into your project, and then that's pretty much it. And then you just go into your, let me find the SteamVR folder. We got the SteamVR folder. Oh, whoops, you know what? I forgot to switch microphones. I was talking into that microphone as if you could hear me, but I was using the lav mic. Anyways, so you go to SteamVR, the prefabs folder, and you drag and drop this prefab into the scene that says camera rig with this blue outline around it. But I already got one of those, so I'm going to delete it. Oh, another thing you probably need to do is delete your main camera, which is this. I don't need that because our new camera is the VR camera, so we don't need the main camera anymore. So yeah, that's pretty much all you need to get the camera rig in there. And then I added a stretched cube that makes up the ground. I added another one to kind of make like a platform. And then every gun is just a rigid body game object. So if I break down this game object prefab, we have a parent game object that's just an empty game object. Then we child a gun model to that. And then here's the other pieces of the gun model, all the different parts. And then we child cubes with box colliders on them to that so that we can get the physical colliders of this gun so that when it hits things, we actually know where the colliding boxes are. And then what I do is I change it to the layer pickupable. And if you don't, you're not going to have that layer by default. So you got to go to add layers like that. And then you just type in here pickupable or anything you want. And then you just assign it here to pickupable, say yes, change children. And now that's ready to go to be a pickupable game object. Let's see, the next thing we need to do is we need to open up this window here. And to get to it, you just go to window. Where is it? You go to window. Oh, right there. Window, SteamVR input. And that will open up this window here. And I think it'll ask you if you want to load up the default JSON files. Oh, by the way, right now, make sure that you have your headset plugged in, SteamVR running, and you're logged in to Steam. Once you have those three things done, go to this window. And what I did was I deleted all of the default stuff there. You can leave it there if you want. You could add your action into the default action set, or you can create your own new action set. I named mine shooter. And then the only thing I added to it was grab. So this is going to be the trigger button. So this is how we're going to know what button we want to grab with. And later we can customize this and set it to any button that we want. For now, I'll just do trigger, but it probably would make more sense to have this be the grip button. So yeah, that's just a grab button, and we have it set to type Boolean. And Boolean is just a fancy word for true or false. So it means you're either pressing the button or not pressing the button. That's all it means. So then we have a pose. So we type in the word pose, and then it says type and select pose. And this is going to be the position of our controllers. This is probably going to already be built into the default controller schemes that you have. But if you decide that you want to delete the default controller schemes, you'll have to do this. But yeah, if you don't see your controllers, it might be one of the reasons why. So I just wanted to make sure I put that in the video. So next, what we do is we go to, I think, save and generate. But I've already done that. So next, you go to open binding UI and give it a second. And there we go. Now it's detected that we're using changes for FPS2 testing. So let's go to edit right here where it says current binding. And then all you need to do is go to trigger or grip button, whatever you want to do. I guess we could easily set this to grip button, but this is with the index controllers. Later, I'll do it with actual finger tracking. So you can actually like just grab the gun. But for now, we'll just assign it to trigger. So you go to trigger, click on plus. I selected button. And then under here where it says click, remember, not touch. Touch is just that your finger is resting on the button. And not every VR controller can detect that your finger is just resting on the button. I believe only the Oculus and the Index can do that. but it can detect click. Click means that you just push the button down all the way. So we're going to select click, and then our only actions are grab. So we're going to select that, but I already have that up there, so I'm going to go ahead and delete that. I don't need it in there twice. But yeah, there we have trigger, use as button, click, and then we're going to set that to grab. Now, the next step that we need to do, also, I don't like this song. I'm going to skip the song. The next thing we need to do is go to edit action poses. Then where it says left hand raw, just select pose and click close. And by the way, since it says mirror mode, we only need to do the left hand, and it should save it for both hands. And then we go down here where it says save personal bindings. Oh, you know what? I think actually you're supposed to do this. Replace default bindings. Let's try that. I think that's where I messed up last time. I was wondering why my controls weren't loading up until I loaded up SteamVR. But, yeah, maybe do both. I don't know. It's either save... No, I think it's replace default bindings. I think that's what you're supposed to click. Right now it says uploading. Okay, yeah. Click on replace default bindings. And then that should save it in your Unity project. We can hit back. In fact, right now we can probably just hit exit. And then that should be our controls all set up. Next, what we are going to do is we are going to... Where am I? We're going to create a script. And I named this pick up object 1. But let's, in this new folder here, I'm going to create a new script and redo it from the beginning so you can see. So when you create a new script, you just right-click, create C# script. And then where it says new behavior script, we want to type in the name of the script so that it renames the file automatically. I'll show you in a second what that means. But let's just pick up pick a name. So we'll call this pick up hands, because these are hands that can reach and pick up things. So we're going to hit enter and then double click on that to open it up in Visual Studio. And as you can see, it took the name pick up hands and put it in there. If at any time I ever want to rename this script right here, so if I like right click and go to rename and call it pick up hand, like that might make more sense because we're going to have one of each of these scripts on both of our hands. So we'll call this pick up hand. But then we're going to get an error message in our console, or at least I thought we would. Oh, okay. It closed out of the file because the name of the file changed. So let's open that back up. And you can see it says pick up hands. And I could have sworn I would have gotten an error message right here. I guess maybe the error message comes when you run the game. But either way, I thought there'd be an error message. But the important thing is that I need to delete the S right there to make sure that this right here says the exact same thing as this right here. So just wanted to point that out. All right. So let's see. Let's break down real quick the different parts of the script when you create a new script. Basically, you're going to put everything inside of this except for up here when you're telling the game what tools you're using. So we have all the default Unity tools and system tools, but we want to add some tools into here, which is valve.vr. And this is just all of the SteamVR plugin stuff. So this is how we are going to get the controls from VR and everything. So up here in this area, this is where I like to put my variables. So this is where the variables of the distance that we need in order to pick up objects, and this can be a variable that we can affect and change, like if we want to make it so you can grab objects from farther away, or if it's like too far away, we can make that number smaller so you have to reach closer to pick up an object. So let me show you what that looks like. So we're going to do public, and typing in public basically means that we can see this variable in other scripts, and we can see this variable in the inspector, which means, so public float. So float is a number that can have a decimal place. That's all that means. That's the type of variable that we're saving. For example, if we said string, that would be like, so let me show you what that would look like. Whoops. String, if we did that variable name, that would be a string of letters. But we want a float because we want a number that can have a decimal place. And then we need the name of it, so we'll call this dist to pickup. And then we need to assign it a value, and I'm going to give it a value of 0.3. How about that? So that would be 3 decimeters. Decimeters? Is that what it's called? But yeah, so basically 30 centimeters because it's measured in meters in Unity VR. So you can see we're getting a little red squiggly line, which means we're getting an error. You just need to put a little F after the number if the number has a decimal place. And then we press a semicolon, which is basically like the period at the end of a sentence to just finish the line of code. And now we have one line of code that saves a variable in our inspector. So also, we need to put this script on something. So we're going to go to our camera rig, go to our left hand and our right hand, and I'm going to temporarily disable that. This script would not be here. This is just the prototype of me just setting up this tutorial. So let's minimize that and check that box to disable it, but you won't have that. Anyways, now we're going to drag and drop this pickup script on to both our left and our right hand. And now both our left and our right hand have this component here, which is our script. And you can see here's our dist to pick up variable that we just made. So I can set this to a larger number, like 6.68, but I'm going to keep it at, how about, let's try like 0.2. I don't know. I keep changing my mind about what distance we want to use. Turn down the music just a little bit. I want to be able to hear my own thoughts. All right, so now let me just take a look at what we need to do next here. All right, so we need a layer mask. We need to boolean to check to see if the hand is currently open or closed. We need to decide whether this is the left or the right hand. And now we need the input source. All right, so also that's an unrelated thing. Let's close that. All right, so dist to pick up. Now let's make a bool, which is short for boolean, and we're not going to do public because we just want to know if the hand is currently open or closed. So we'll call this hand closed, and we'll have it by default equal false. And then inside of here, update, which we actually want to change to fixed update because this script is going to be affecting the physics of the game. And basically you want to use regular update. That's going to go as fast as the computer can possibly go frame by frame. But fixed update is going to go at a steady rate that matches the physics system. So we're going to switch it to fixed update. All right. Next, we need, what do we need next? Let me double check. All right, let's do the enum for hand open and close, or yeah, I guess we do need that. All right, so let's do a public enum, and an enum variable is basically a variable that can choose from a selection of options, and we need to create our own custom set of options. So right now we're going to create an enum called hand LR to determine whether it's the left or the right hand. And then we need an opening and closing bracket like that. And then also let me increase the size of this text to make sure you can see it good. So the first option will be left, the second option will be right. And then that's all we need for declaring the enum type. Now that we have the type, we're going to use that type to create an enum variable. So basically a variable of type hand LR, which is what we just created. So now let's create a public hand LR, and we'll call this which hand, and we'll have that by default equal hand.lr.left, which means that we're selecting the left hand. So if I save that and now go back into Unity, we'll get another variable type down here. So you can see that we don't have the hand closed Boolean variable showing up right here because we didn't include public in front of it. But anyways, we have which hand and we have left and right, and we can select left and right from this drop-down menu. So we're going to keep left as left, and now I'm going to select the right and change that to right. And now we have our left and our right hand selected as left and right. And now we need to write some code to actually do something with that. So let's go to this. So we need to save our hand source. So this is going to be which object or controller from SteamVR are we going to use to get these button presses from. So I'm going to make a public SteamVR, what is it called? Input source? Input source. Was it source or sources? Sources. You add a little S at the end of that. And we'll call this hand source. And we'll have this equal by default left hand. So if I type in SteamVR input sources dot, it'll give me a list of all these different things that I can choose. So this is it of type enum? Yeah, it's an enum. So this is an enum that SteamVR made for us to use. So we're going to select left hand. And now inside of void start, so this happens one time at the start of the game or whenever this game object is created, which in this case is going to be at the very start of the game. So inside of void start, we just need a little if statement that says if we have set this to the right hand, select the right hand input source. So if which hand, whoops, not win zones, which hand equals, and we need to press equal, not just, so when you do one equal like we do up here, that's to set a variable. If you do two equals right here, we're asking if the two different things equal each other. So if which hand equals hand lr dot right, then hand source, there it goes, hand source equals, so we're setting it to equal hand sources dot right hand. There we go. And you know what, now that I'm thinking about it, so let me temporarily comment out these lines of code. That's a lot of lines of code, but public, you know, now that I think about it, I think in this script I didn't make it public. So let me see what happens when I make it public, just out of curiosity. All right, load. Okay, hand source, left hand. Okay, so totally could have done it this way. That actually, you know what, let's keep it that way because that makes a heck of a lot more sense. Change that to right hand. Okay, so actually let's delete all that stuff. I'm just realizing now that all this other enum stuff was kind of, I guess that was the only thing we were going to have inside of void start. So we can always just type in void start if we want to bring it back. So I think that's actually all we need. So that's actually a lot simpler way of doing it. Okay, so you can do it either way. In video games, there's a million different ways to do the same thing. So inside of fixed update, what's the first thing we're going to do is just check to see if the hand is open or closed. So we are going to do if hands, wait, no. How does it start? SteamVR actions. Okay, got it. So SteamVR actions. And also, I realized last night that this SteamVR actions does not show up until, wait, it's calculating. There we go. Until you go through this whole menu and click on save and generate. And then it will recompile the script. You'll probably have to close the script and reopen it. And then SteamVR underscore actions will appear. Yeah, so that's that. And we're going to type in, whoops, SteamVR actions dot shooter grab, because that's what we named it over in that other SteamVR input window. And we're going to do dot, what is it, get get state. That's what it was, dot get state. So this will tell us whether it's currently pressed or not pressed, basically. It'll just return us a true or false. And we're going to type in hand source, because that is where we selected whether it's the left or the right hand, or basically which controller we're getting the buttons from. And I believe that's everything we need inside of there. And if that's true, we're going to have hand closed equal true, because we're pressing down the button. That means our hand is closed. Else, so if we're not pressing down the button, then our hand's going to be open. So we're going to set hand closed to false, because open is the opposite of closed. So hand closed equals false. And now we got a true false variable that tells us really quick. So we just need to say if hand closed, we'll know whether or not the hand is open or closed. Next, let's check to see. All right. So we're going to go through this big if statement here that says if holding is false. Turns out, now that I'm looking at it, that was unnecessary. So let's skip that step and just say if hand is not closed. So if exclamation mark hand closed. So basically putting an exclamation mark in front of it tells Unity that we're checking to see if it is false instead of checking to see if it is true. So if the hand is open, and then we're going to hit enter, opening and closing squiggly brackets to say that we're going to be doing multiple lines of code inside of these squiggly brackets if hand closed is equal to false. So that's going to be all of this stuff here. So let's create a an overlap sphere using this line of code here. So we need to type in collider. So this is going to be a variable of type collider. So those box colliders that I showed you earlier, those are a type of collider. So that would be a variable type that's going to remember this collider that we've collided with. And then we need to give it an opening and closing square bracket to make it an array. We don't actually need an array. It just so happens the overlap sphere wants to give us back a list of every object that it found. And we're just going to take the very first item out of that list because we don't need the whole list. Now we need a name for it. I'll just call it colliders lowercase. And then we need to decide what we're going to set it to. And we're going to set it to a array of colliders that is returned to us from physics.overlap sphere. And now we just need to tell it where the sphere is, the radius of the sphere, what layer the sphere is going to look for, and then using all that information, it's going to give us back a list of all the colliders that it found that matched that criteria. So position, we're going to do transform.position. So when we just type in transform on its own, it's referring to the transform or the position, rotation, and scale components of any game object. It's going to give us back the transform of the game object that this script is attached to. And since we attached it to our hand, this is going to return us the position of our hand. Next, we need to give it the radius. So this is how big the circle is. So this is the distance away that we want to be able to pick up objects. So we simply put in the variable dist to pick up. That way, when we adjust dist to pick up in the inspector, it also changes right here automatically. Also, I think I'm about to sneeze. Okay, I did not sneeze. I am going to sneeze. No, I'm not going to sneeze. Okay, public layer mask. We need a new variable of type layer mask. And let's call this pickup layer. And normally with all the other variables, I like to say equal and then give it a default value. But for layer masks, it's a little bit easier just to assign it in the inspector. So I'm going to hit save. Oh, whoops. No, before I save it, let's finish this line of code. So give it the, what am I looking for? Pickup layer? Pick up layer. There we go. So I put the pickup layer in there, give it a semicolon to finish it off, and now that line of code is finished. So now let's go into the inspector and take a quick look at what it looks like now. So now we have a pickup layer right here, and we can choose what layer we want. So let's select both the left and the right hand because we want to make sure that both of them get this layer. And we go to pickup layer and we select pickupable. And out of this list, you can pick multiple things, but we only want the pickupable. Oh, whoops, sorry, you can't see it because the screen. All right, so there we go, pickupable. So you just want to select it right there, just like that. Move that back into place. All right, so that all is going to give us a list of colliders in here. Next, we need to check to see if this list is longer than 0, because if it equals 0, that means we're not near anything and there's nothing to be picked up. So if colliders.length is larger than 0, then we will move on and do the next thing, which is set our hold target to equal the first item on the list. So also I need to create a variable to save. So we're going to, oh wait, no, this is going to be of type rigid body. So this is going to be the rigid body component of the game object that we're currently trying to pick up or currently picking up. And the rigid body, like I said, is the physics component. So this is going to be what makes objects bounce around and stuff. What's going to actually give them momentum and be able to collide with other objects. So we need to affect the rigid body in order to have all of these cool physics in the game. So we'll call this holding target. So this will be the target that we're trying to grab. So if the length of colliders is larger than 0, so that means currently our hand is open and we're just scanning for and getting ready to pick up an object. So this would mean that our hand is floating over a gun because the length of the colliders that it found with the layer pickupable layer, you know, we know that at least one of those guns is nearby our hand. So we'll take the first item on the list, which I keep going back to my other script because I want to remember. Oh yeah, we got to save hold target equals colliders. And then we want to put in the square brackets the number of which item we want to take out of the list. So we're just going to take the first item on the list and arrays, which is the square brackets with a list of variables. So if it's a variable type that says a list of variables, it's an array. And arrays always start at 0. So you would think the first item on the list would be 1, but because it's an array, the first item is actually 0, and the second item is 1, the third item is 2, and so on. So we do 0 to grab the first item, but the item on this list is a collider. So we can't save a collider into a rigid body type variable. You need to put a rigid body into a rigid body type variable. So we need to find the rigid body that is attached to this collider. And the way I coded it, or not coded it, the way I set it up in the Unity editor is that the rigid body component is on the very top parent empty game object that holds the gun and all of the colliders together. So we're going to collider.transform. So this is going to give us the transform components. So the position, rotation, scale, and all of that good stuff is going to give us back that information about our collider. But still, transform is not what we're looking for. We want to know the parent of our transform. Because like I said, when we set up these guns here, so here's the parent game object that I have selected here. And then I have the gun attached to that, all the different gun parts attached to that. And then here is the actual collider game object. So it's going to return us this transform component right here when we collide with that with our sphere overlap code. So it's returning us this, but we can say transform.root, and what that will do is it'll just keep going up and up and up until it finds the topmost game object that holds everything together. And that is where our rigid body is. So let's do that in code. So we got transform. You just type in transform.root. So now we have selected this transform right here on the parent game object that's holding everything else. And then from that, we want to do dot get component. And the component type that we are going to get is rigid body. Also, if you forget to add a rigid body to it, it'll give you an error message when you try to get a rigid body. That or it'll just save the rigid body as null. Maybe you won't actually get an error message. But anyways, so now we have saved the rigid body of the gun. So now we can affect the physics of the gun by affecting the holding target variable. And let's see. Oh, then we need to say, but if there's nothing nearby, set it to null. So else holding target equal null. And I, for some reason, thought there was going to be more than one line of code here. So those squiggly brackets are actually unnecessary. So if we do find a game object with the overlap sphere, we're going to save the rigid body of it into holding target. Otherwise, we're going to set holding target to nothing. Null means nothing. We're going to set it to nothing, and then that will mean that we're still looking for something to grab. All right, so this is everything we need to do while our hand is open, and we're just scanning for an object to go pick up. So what's next? We need to say else. So now if our hand is closed and we have a target to pick up, we'll actually pick it up. So we're about to get into the really good part of the code. So I'm going to say else. And then inside of here, we need an if statement that says if holding target. And all we need to just do is just say if holding target. And if it has a target, it'll return true. If it doesn't have a target, it'll return false. So if holding target, then physically move. Oops, I can't type. Object to hand. So everything in here will be us moving the object to our hand. So first we want to affect the position, because that's the easy part. We're going to just override the current velocity of the gun or the object that we're holding and just say we're going to give it the exact amount of force that it needs to just instantly move to our hand. And let's see, let me just give myself a little refresher. That's this line of code right here. So yeah, super easy. So holding target, so this is the rigid body that we're trying to hold. Dot velocity equals, and now we can change the velocity. And by the way, velocity just means which way in 3D space we're currently moving. Not only the direction that we're currently moving, but also the speed that we're currently moving at. So we're just going to override this and set it to move it directly into our hand. Now you might think that that would mean that the next frame, the gun would overshoot and fly past your hand. But because the next frame, before we move it again, we give it the exact amount of force that it needs to move to our hand. So if it's already in our hand, it just won't apply any force. It'll just apply 0 velocity because it's already there. So we're going to have this velocity equal from where it currently is to our hand. So our hand is our target. So we type that in first, and that's transform.position. And now in order to get a from to vector 3, basically we first write where we want to go to, and then we minus where we're coming from. So to minus where we're coming from, that would be holding target dot transform dot position. So when I type in just plain old transform dot position, it's the game object that this script is attached to, which is our hand. But I want to know the position of the gun, which is holding target. So I type in dot transform to get the transform, this component right here of the gun, and then just type in dot position, and now I have the position of the gun. And now let's put that into parentheses. So that's going to give us back our vector 3 velocity variable, but it's going to return it in meters per second. So basically this would give us the velocity that we would need to move the gun into our hand over the course of 1 second. But that's too slow. We want it to move into our hand instantly in 1 frame. So to do that, we simply do divide by time dot fixed delta time. And fixed delta time is a number that is how many seconds until the next frame for physics. So since there's multiple frames per second, this number is going to be smaller than 0. And whenever you divide something, a number, by a number that's smaller than 0, it actually ends up making the result bigger. So this is going to make us move faster by the exact amount that we need to instantly snap it into our hands. So that's all we need to be able to grab an object. Next, to move the object into our hand. Now we need to rotate the object into our hand. So this is just a little bit more confusing. So first, we need to set the max angular velocity. I'm just going to copy and paste that. So holding target. So this is, not hold target. Holding target. There we go. So our holding target is the rigid body that we're trying to hold, and we're going to set the max angular velocity to 20 or something larger. By default, this number is set to 7, and that's how quickly this thing can rotate. And what I discovered is if you're holding a gun and you move it really quickly left and right, the gun will lag behind because the engine is not letting the gun rotate fast enough, because our hand in VR can rotate pretty fast. So if we set that to a higher number, like 20, that just increases how fast the gun can rotate. So that's super easy. Next, we need to do this line of code here to find our delta rotation, which basically means delta means from to. So this is going to be our from to rotation. So it's going to be from where the gun's currently rotated to our hand rotation. So let's put that together. So this is going to be a variable of type quaternion. And quaternion is basically a fancy word that means a rotation in 3D space. So quaternion, delta rot, short for rotation, equals, let me double check, make sure I get this right, transform.rotation times quaternion inverse holding target transform.rotation. All right, so this sounds super complicated, but basically it's a very standard rotation quaternion formula that basically means from to. So we are starting with where we want to go to, which is transform.rotation, so the rotation of our hand. And now to get our from, you multiply by quaternion dot inverse, and then inside these parentheses we write where we're rotating from. So our from in this case is holding target dot rotation, and then boom, there we go. Let me just double check to make sure I got that correct. Yeah, dot rotation. I was thinking I need to write dot transform dot rotation. Is that actually unnecessary? Maybe it is. I've been learning a lot of new things in the middle of this tutorial, and this tutorial's gone on a lot longer than I wanted it to. I thought it was going to be 20 minutes, but I guess this is going to be an hour-long tutorial. Sorry about that, but hopefully this is good information. Hopefully this is helpful to people. So let's now go to the next line of code. All right, so this is a little bit weird. So this line of code I actually got from the Unity forums thanks to somebody named Bob Sir. Somebody figured this out, so this is really cool. Basically, we convert our quaternion into Euler angles, which basically means kind of like how your angles are measured in here, where you have 360, 360, 360, and you like rotate it in the Unity editor. That's basically how an Euler angle works. So, wait. Here we go. So our Euler angles, we're going to create a new vector 3, and basically we copy and paste the same thing for our x, y, and z. So the problem with Euler angles is a lot of times, like, you know how in Zoolander he can only turn left, so he ends up spinning all the way around if he needs to turn right? That's kind of what Euler angles do when the rotations are just not perfectly ideal for them. So the angle can be set to 350, but it needs to get to angle 10. So we know it would be fastest for it to just go all the way up to 360, cross the 0, and then go up to 10. That'd be the shortest rotation. But sometimes they get confused and they think, oh, 350 is larger than 10, so I need to go down. So it rotates all the way around. So it ends up doing all these weird loop-de-loops. So basically, we need to fix that and just tell it to give us the shortest angle on the x, the y, and the z. This would be way more convenient if there was a function that lets you do it for all three at the same time, but we kind of got to just manually go in there and individually do it for the x, y, and z, and we're just using the formula mathf.delta angle. So mathf.delta angle is just a function where you give it where we're going from. So in this case, it's 0 because we want to rotate it to our target, and where it's coming from. And if we have a case where you're like at 350 and you need to get to 0, it'll just go straight to 0 instead of rotating all the way around. That's basically what delta angle does. And then we save all that inside of Euler rot, and then we quickly multiply it by 0.95 just so that we don't overshoot. I'm not entirely sure if this was completely necessary. I think it smooths it out just a little bit. Then, very important, we need to multiply it by mathf.deg to rad, which is degrees to radians. I always forget this step in everything that I do, and it's so weird that in Unity, like 50% of everything is measured in radians and 50% of everything is measured in degrees. Why can't they just have both of them all the same? I don't know. Maybe there's a good reason. I don't know why. But you just got to check that Euler angles, Unity doesn't really tell you, but it is for sure always in 360 as far as I know, and 360 is degrees, and we need to convert that to radians, which is basically just another way of measuring degrees with trigonometry. So yeah, so we convert that into degrees to degrees to rad, and that'll convert the degrees into radians. And we need to do that because holding target.angular velocity is measured in radians per second. So holding target, this is the gun that we're holding, and then angular velocity, this is just like velocity, this is where we're currently moving, but instead of moving, it's where we're currently rotating or spinning. And we set that to equal our Euler rot, so everything we just calculated right here. And then, just like we did up here, where we got to divide it by time.fixed delta time, we're going to divide it by time.fixed delta time, so it doesn't take 1 second to get there, it takes 1 frame to instantly get there. And that's pretty much it. Let's go over here. So let me copy and paste this, because I don't want to type in all of that twice, and I just explained all of it. So let's see. Delta rot, did I name it? Yeah, I named it the same thing. except I think that's just an ing in holding. And now I think all of that is working. So let's jump into VR just to double check that all of it's working, but I think that this is the end of the tutorial. So switching microphones, so now I can walk around and you can still hear me. And let's turn on the game. Oh, let's go to console. We got no error messages, that's good. All right, fingers crossed this actually works. Let's go into VR mode and let's jump into VR. Hopefully this works. It's gonna be kind of embarrassing if it doesn't. All right, we're in the game. We got controllers and I can pick up game objects, yes, and I can bounce them. Actually, why don't I go ahead and show you how to do that bouncy and slidey stuff real quick, because that's a lot of fun. But yeah, you saw me mess around with all this in the beginning of the game. You don't need to see me mess around with it more, even though it's actually way more fun than it should be. There's so many different, like, just physical games you could create from just this one tutorial. So yeah, let me just show you real quick where the physical properties like bounciness and slidiness actually are. So switch back to desktop mode, switch the mics. And there we go. All right, so in order to get the bounciness and slidiness, you basically create one of these physic materials. So if I create a new one, you go to create physic material, and let's call this kinda bouncy. And inside of here, I can adjust things like my dynamic friction, static friction, bounciness, which is set to 0. So let's set that to, we'll set it to 1, which is the maximum. And then bounce combined. The other one I had set to maximum to give it like maximum bounciness. But this one, let's do average, just so that it's like just a little bit bouncy. And then you go to your cubes or your colliders of your gun, and then you can see right here under box collider where it says material, we're gonna drag and drop kind of bouncy. And also let's scale up this gun, just because otherwise I won't be able to tell which gun is kind of bouncy. So let's run it. Go back into VR mode. Turn on the mic. All right. And let's see if this worked. All right. Oh my gosh. Oh, that's so funny. Sometimes just the smallest things can be so entertaining in VR. But let's check out the bounciness of this giant gun. Okay, it's like a little bit bouncy. Bounce, bounce. You can see the regular guns, when I throw it down, they barely any bounce whatsoever. Like, they really don't bounce at all. But the red guns bounce. Those are really fun. That would make for a really fun game where like every gun has different physical properties. But yeah. So that is the end of this tutorial. I apologize that it went on for so long, but I once heard, I can't remember who it was, but apparently there's some philosopher, like a Greek philosopher or something, that wrote somebody a letter like that said, "I'm sorry this letter is so long, I didn't have time to make it shorter." That's kind of the situation that I'm in right now. I don't have time to make these videos shorter. I really wanted this to be 20 minutes, but clearly we're way over 20 minutes. So, oh well, I guess hopefully this is still educational and useful. Like this video if you found it helpful. Check out Jet Island if you want to see what kind of games I make in my spare time. Not spare time. That's kind of a little bit more than spare time. It's kind of what I do full time. But yeah. So if you want to check out my games, there's going to be a link in the description below. If you got VR, yeah, I think that's pretty much everything I want to say. So I will see you in the next video. Until then, I'll see you later, and keep making games.